Dear friends, today we will study about the solution of a non-homogeneous linear differential equation of the constant coefficients. Last class we have studied how to find the solution of homogeneous linear differential equation. Now we will study the solution of non-homogeneous linear differential. That too, we will consider first of order 2, then it can be extended to order 3, 4, 5 and so on. Okay. Now let us consider the differential equation of the form d square y by dx square plus a1 into dy by dx plus a2 of y is equal to, say, some x or f of x, where this x is purely the function of x. Okay. Now the solution of a non-homogeneous differential equation is given into two parts, that is y is equal to cf plus pa, where this cf is called a complementary function, which is the solution of corresponding homogeneous differential equation. Okay, and pi is called the particular integral of the solution with respect to the x or f of x. Okay, now complementary function cf can also be denoted by sometimes yc or phi of x, and particular integral is denoted by pi or sometimes yp or sometimes xi of x. Okay, now you already know how to find the first part is nothing but write down the auxiliary equation, find the roots. After finding the roots, depending on the nature of the roots, you have to write down the solution of the homogeneous differential equation. That becomes the solution for the corresponding homogeneous differential equation. But when you consider non-homogeneous differential equation, that is called as a complementary function. Okay, now we'll discuss about the how to find the pi, that is particular integral. Okay, now for that purpose we need to understand what is inverse differential operator. That is inverse differential operators. Let us consider a pi of the given equation, that is y double dash or d square over dx square plus a1 into y dash plus a2 of y is equal to x, which is a function, the function xi of x given by xi of x, such that it satisfies the given equation. That is given equation is LD of y is equal to x, where LD is nothing but d square plus a1d plus a2, and d, capital letter D is d by dx, d square is d square by dx square. Then pi is a function that is denoted by xi of x, which satisfies the given function such that LD of, that is, we need to replace that y here by x. If we replace that y by x, then y by xi of x, that should be equal to the RHS. That is, then only this is called a solution of the given equation. Therefore, now we are required to find this pi xi of x. So xi of x is equal to, simply just if you transfer to this side, that becomes 1 divided by LD of x. Okay, that is x or f of x. Okay, now this LD, 1 divided by LD, is called the inverse of the differential operator LD, because you already know this is a differential operator, D is a differentiation, D is the differential operator, which is L indicates linear. Okay, so as we know, differentiation and integration are reciprocal of each other. So 1 divided by LD is the inverse differential operator, which is nothing but integration. Okay, now I hope you understood what is inverse differential operator. Okay, now let us study about the how to find the pi using, there are two methods. One is direct method and another one is shortcut method. Direct method becomes a little bit lengthier and tedious or complicated. So what we will do, we will study about shortcut methods to find pi when x is in some particular or standard forms. Okay, only standard forms we will discuss, that is x or f of x, that is in the equation 1 LHS, that is LHS maybe of the following 5 palms. Okay, that is type 1, x may be k into e to the power ax, that is x may be exponential function, and k and a are the non-zero constants here. K and a are the non-zero constants because if you take a is equal to 0, this e to the power 0, this becomes 1, and it becomes a purely constant. Okay, so then if k is equal to 0, 0 into anything, this entire quantity becomes 0. So we should take k is equal to strictly greater than 0 and a is equal to strictly greater than 0. That is case number 1. Then type 2 x may be of the form k into sine ax plus b or k into cos ax plus b, that is trigonometric forms. Here also k and a are strictly non-zero constants, and b may be sometimes, this b may be sometimes 0. Okay, then next type 3 is as x is equal to, it may be a polynomial function. It is denoted by Pn of x, that is nth degree polynomial. So or it may be of the form x is equal to a naught into x raised to n plus a1 into x raised to n minus 1, a2 into x raised to 1 minus 2, so on, a raised an, where a naught, a1, a2 and an, all these are constant. And type 4 type 4, it may be x may be of the form e raised to ax into v, that is exponential function, that is a type 1, into v, where this v is strictly, v may be strictly type 2 or type 3, that is v may be sine or cos, that is a trigonometric function. Type 3 means it is a polynomial, it may be polynomial function. Okay, then type 4, x is equal to, that is f of x is equal to x into v, where this v is a purely or strictly type 3, that is v is a polynomial case. Okay, these are the 5 types of the standard form of the x or f of x when we go to the solve non-homogeneous differential equation. That is, x may exist in any one of these 5 forms. Depending on the which type that exists, we are going to find the pi. Now we will discuss about the how to find pi case by case. Okay, so dear friends, we know how to, now I think you got to know how to solve this non-homogeneous differential equation. Non-homogeneous differential equation solution is given into 2 parts. Y is equal to cf, that is complementary function plus particular integral. Now we know how to find the complementary function, that is complementary function is nothing but solution of the corresponding homogeneous differential equation. Now mainly we will concentrate on how to find pi, that too when that RHS part is particularly in some standard form of the function of x. Okay, one by one we will discuss now. That is case number 1 we will consider, that is type 1, how to find pi when x is an exponential function or x is of the form k into e to the power ax. We should consider k and a should be non-zero numbers. Now, so if it is a case, then particular integral is given by k into e to the power ax divided by L of a. That is L of a means LD will be given. So you need to replace L of in the first case. That is, this procedure you have to do, this method you have to apply whenever this a, that is a means this is coefficient of x in this equation. Coefficient of x will be in the e to the power, that is coefficient of x, that is a, that should not be equal to the any of the roots you got after solving the auxiliary equation. Okay, then under that condition you have to write directly k into e to the power x divided by L of a, that is replacing a by d in the denominator. Okay, then next one is, if suppose after finding roots, if suppose this a, if this is equal to one of the root of the all the roots you got after solving the auxiliary equation, it is called a simple root or a single root. Then the particular integral is written as x into k into e to the power ax divided by L dash of a. That is, you need to differentiate L of d once, and after differentiating you have to substitute wherever d is there, you have to substitute L is equal to a, where keep in mind where a is a coefficient of x which is in the power of e. Okay, that is one rule is there. How many times if you differentiate, those many times you have to multiply numerator by those many x's. Okay, then last case in the second order differential equation, if it is third order, fourth order and fifth order, it can be continued. So last case, that is if a, that is a coefficient of x, if it is equal to both the roots. This is possible whenever, if it's a quadratic equation, it is possible whenever both the roots are real and equal. In that case, what we have to do, we have to find the pi, we have to differentiate denominator two times. When you differentiate denominator two times, numerator should be multiplied by x square, and x square into k into e to the power ax divided by l double dash of a should be written. And here, if you put in l of d, if you put d is equal to a, that will be equal to 0. uh, in the first order derivative, there's l dash of d, if you find, and if you put a is equal to 0, that also will be equal to 0, and l double dash will not be equal to 0. Now, using these rules, let us try to find solution of some non-homogeneous differential equation. Let us consider example number 1, that is d square over dx square plus 6 into dy by dx plus 9y is equal to 5 into e to the power 2x. Now, by observing this, LHS is not equal to 0. LHS is equal to some non-zero quantity here, and that too, in particular, it is of the form 5 into e to the power 2x, that is exponential term is present there. So we think that case number 1, that is any one of these three can be applied here. So that depends on nature of the roots. After finding the nature of the roots, we are going to decide which one of these is applicable to find pi. So first, you need to understand, since this is a non-homogeneous differential equation, the solution is given by y is equal to cf plus pi. Y is equal to cf plus pi. Therefore, to find cf, first let us rewrite this equation in the simple form as d square plus 6d plus 9 into y is equal to 9 of y is equal to 5 into e to the power 2x, where we have substituted here d by dx is equal to d and d square by dx square is equal to d, and after rewriting we will get this form. Therefore, the auxiliary equation is written as L of m is equal to 0. That is, this is your LD here. So in that LD, you need to put m, so it becomes L of m is equal to 0. That is m square plus 6m plus 9 is equal to 0. Now, by observation, if you are perfect, you can write directly this one. See, this is in the form a square plus 2ab plus b square form. So you can write m plus 2 whole square directly. Or if you are not familiar with that, this, since this is a quadratic equation, we need to concentrate on this number, constant number, and coefficient of m, so that you have to find factorization. That is, factorization is possible or not, you have to check. That is 9, you have to find two numbers such that, considering 9, if you multiply, you must get plus 9. If you add, you must get plus 6. Whether it is possible to find two such numbers or not. Here it is possible. Here 3 into 3, it is plus 3 into plus 3 is plus 9, plus 3 plus 3 is plus 6. So it is possible. So you can write this given equation as, that is auxiliary equation as, m square plus 3m plus 3m plus 9 is equal to 0. So from the first two terms, you can take m common, and we can write it as m plus 3, and last two terms, that is third and fourth term, you can take 3 common, you can write it as m plus 3. Now from this entire equation, you can take one factor, m plus 3 is common there, you can take that common, and from the first term you left with the m, and the second term you left with the 3, you can write it as m plus 3. Therefore, through you will get two factors, m plus 3 into m plus 3 is equal to 0. Now, by making m plus 3 is equal to 0, you will get one of the root as m is equal to minus 3, and by making another factor m plus 3 is equal to 0 also, you will get m is equal to minus 3. Therefore, m is equal to minus 3 and minus 3 are the roots which are real and equal. Therefore, you know how to write the complementary function. Therefore, the complementary function is nothing but a solution of the corresponding homogeneous differential equation, that is written as yc is equal to c1 plus c2x into e to the power minus 3x. Now, main thing is we need to find pi. To find the pi, we will write down first as yp is equal to, that is pi is equal to 1 divided by l of d into 5 into e to the power 2x. Okay, then this 1 divided by d square plus 6d plus 9 of 5 into e to the power 2x. Now let us concentrate here. Here a, clearly a is 2 here, which is not equal to the any one of the two roots we found. Okay, therefore the particular integral is given by 5 into e to the power 2x divided by l of 2. Already you know what is this l of d there. Wherever d is there, replace d by replace d by a, that is a is equal to 2 here. Therefore that becomes 2 square plus 6 into 2 plus 9, that is 5 into e to the power 2x. 2 square is 4, 6 into 2 is 12 plus 9, that becomes 9 plus 3 9 plus sorry 9 plus 4 is 13, 13 plus 12 is 25. So that becomes 5 into e to the power 2x divided by 25. After simplification you can simplify 5 ones are 5 5s are, so it becomes e to the power 2x divided by 5. Therefore the particular integral is required particular integral is yp is equal to e to the power 2x divided by 5. Therefore the general solution, here your solution is not over, you have found just cf and pi. Now you need to combine them to write the general solution. Therefore the general solution is written as y is equal to cf plus pi, which is y is equal to c1 plus c2x into e to the power minus 3x plus e to the power 2x into 5, which gives you the complete or general solution of the given differential equation. Now let us consider another differential equation here, non-homogeneous, that is solve y double dash plus 4y dash plus 3y is equal to 2 into e to the power minus 3x, or the same equation can be given as a d square y by dx square plus 4 into dy by dx plus 3y is equal to 2 into e to the power 3x, both are one and the same. So now after substituting, after putting d is equal d by dx is equal to d and d square by dx square, d square by dx square is equal to d square by dx square is equal to d square. Okay, and simply after simplification you will get d square plus 4d plus 3 of y is equal to 2 into e to the power minus 3x. Again you can observe here LHS is not equal to 0, so it is a non-homogeneous differential equation. And now when it is non-homogeneous differential equation, then we need to concentrate on this quantity. It is a exponential function, so type 1 is applicable to find the pi. Therefore to find the CF now, therefore the auxiliary equation can be written as L of m is equal to 0, that is m square plus 4m plus 3 is equal to 0. Now since this is a quadratic equation, first thing we need to concentrate on constant number, and then we need to concentrate on this, so that consider 3 here, so that if you multiply you must get plus 3, if you add you must get plus 4. So the two numbers are plus 3 and plus 1. If you multiply you will get plus 3, and if you add you will get plus 4. Okay, therefore the given equation can be written as m square plus m plus 3m plus 3 is equal to 0. Now from the first two terms you take m common, it becomes m plus 1, and from the last two terms you take 3 common, it becomes m plus 1. So here m plus 1 is the common factor. Taking m plus 1 as a common factor, from the first term you left with the m, you write here, then from the second term you left with a plus 3, you write it here. So the two factors, that is given equation becomes m plus 1 into m plus 3 is equal to 0. So m plus 1 is equal to 0 is one of the factor, m plus 3 is equal to 0, that is you make equal, both the factors make equal to 0. And on solving, m plus 1 is equal to 0, by transferring this 1 to this side you will get m is equal to minus 1, and by transferring this 3 is equal to this side you will get m is equal to minus 3. Therefore the roots will be, the roots you got as a m is equal to minus 1 and minus 3. You can observe these two roots are real and distinct. Therefore the complementary function or yc is written as c1 into e to the power minus x plus c2 into e to the power minus 3x. Now main agenda is to find a pi, particular integral here. So pi can be written as 1 divided by LD of 2 into e to the power minus 3x. Now you observe here coefficient of x is minus 3, that is a is equal to minus 3 here, which is equal to one of the roots, that is one of the root is minus 3. Therefore the particular integral is given as, sorry, here you should write as particular integral. Therefore yp it should be written as 5 into x into e to the power minus 3x divided by L dash of 3, where L of d is d square plus 4d plus 3. L dash of d becomes, after differentiating this with respect to d, L dash of d becomes 2d plus 4. 3 is a constant number, so that becomes 0. Now in this L dash of d, wherever d is there, you have to put a coefficient of s. you have to put value of the coefficient of x, that is value of the a, that is it becomes 5 into e to the power 5x into e to the power minus 3x divided by 2 into minus 3 plus 4, which will become 5x into e to the power minus 3x divided by minus 6 plus 4. After simplification you will get that 5x into e to the power minus 3x divided by minus 2. Therefore the yp is minus 5 by 2 times x into e to the power 3x. So this is not the actually required solution. So to find the general solution, we have to add yc and yp, that is cf and pi, that can be written as y is equal to c1x plus c2 into e to the power minus 3x minus 5 by 2 times x into e to the power minus 3x, which gives you the required solution. Okay, now let us take one more example here, that is solve y double dash minus 8y dash plus 16 of y is equal to 3 into e to the power 4x. By observing this, you will come to know that this is non-homogeneous differential equation, and concentrating on this, you will come to know that this is purely exponential function. So we can, when we find pi, we have to use rules for finding the pi depending on the nature of the root and depending on the value of the a. Those two things should be kept in mind. So rewriting this equation, this can be written as d square minus 8d plus 16 of y is equal to 3 into e to the power 4x. Okay, now we have to find first complementary function. Therefore the auxiliary equation is written as L of m is equal to 0, which can be written as m square minus 8m plus 16 is equal to 0. Now observing this, this is also a perfect square. You can write it as m minus 4 whole square, or you can find two numbers. Since this is a quadratic equation, you can find two numbers such that if you multiply, you must get a plus 16, and if you add, you must get a minus 8. Those two numbers are minus 4 and minus 4. Okay, so that the given equation, I'll write in this side, the given equation can be written as m square minus 4m minus 4m plus 16 is equal to 0, plus 16 is equal to 0. So after taking m common from this, this becomes m minus 4, and from these two take minus 4 common, you will get m minus 4, which is equal to 0, and after simplification you will get m minus 4 into m minus 4 is equal to 0, or you can written as m minus 4 whole square is equal to 0. So making these two factors equal to 0, you will get m is equal to 4, m is equal to 4, that is the roots are real and equal. Okay, the roots are real and equal. Now therefore the complementary function can be written as c1 plus yc is equal to c1 plus c2 into c2x into e to the power 4x. Now the main thing is we have to concentrate on to find the pi. Now pi, that is yp, can be written as 1 divided by ld into 3 into e to the power 4x, t into e to the power 4x. Now here a value is 4, and here you can observe here both the roots are equal to 4. Therefore this coefficient of x is also 4, and both the roots is also 4. So this a is equal to 4 is equal to both of the roots of the auxiliary equation. Therefore the complementary function, that is, can be written as, particular integral can be written as x square into 3 into e to the power 4x divided by L double dash of 4. Now we will find the L double dash here. That is L of d is d square minus 4d plus 16. Therefore L dash of d becomes 2d minus 8. L double dash of d becomes 2, because if you differentiate here, differentiation of d square is 2d, 8 is constant, keep that is, differentiation of d is 1, differentiation of constant term is 0. Once you differentiate, after differentiating it 2 times, 2 as it is, differentiation of d with respect to d is 1, this minus 8 is constant, that also becomes 0. So it becomes 2 only. So the particular integral becomes 3 into x square into e to the power 4x divided by 2. Therefore the general solution is given by yc plus yp, that is the general solution can be written as c1 plus c2x into e to the power 4x plus 3 by 2 times x square into e to the power 4x. Okay, now you observe here, if it is your differential equation is equal, if your root a is equal to, if your a coefficient of x is equal to one of the root, you are multiplying denominator by once, and you are you are differentiating denominator one time, and when you are differentiating denominator one time, you are multiplying numerator by 1x, and when you are root this a is equal to both of the root, that is 2 of the roots, then you are differentiating denominator, that is L of D twice, and you are multiplying it by x square. That thing is need to be kept in mind. We will consider one more example, that is solve d square plus 4d plus y plus 5 of y is equal to minus 2 into cos hyperbolic hx. Now let us not concentrate on this now, when we will concentrate this on when we go to find the pi. So now for this we will consider this is a, since this is not equal to 0, this is non-homogeneous differential equation. Therefore the solution of this is given in two parts, that is y is equal to cf plus pi. Now first we will, let us discuss on the, concentrate on the finding the value of cf here, that is okay. Therefore, since your equation is given in the simplified format, so you can write directly the auxiliary equation as L of m is equal to 0, which becomes m square plus 4m plus 5 equal to 0. Since this equation is a quadratic equation, let us try to find a, let us try to factorize it. That is, a constant number is 5, and this middle term is 4. So you have to find first write down the 5 here. You have to find two numbers such that if you multiply you must get plus 5, and you have to find those two numbers such that if you add you must get plus 4. So here clearly it's not possible to find two such numbers, so factorization is not possible. So we'll go for a Sridhara's rule, that is x is equal to minus b plus or minus underscore root b square minus 4ac divided by 2a. Here a is equal to 1, b is 4, and c is 5. Therefore m is equal to minus 4 plus or minus underscore root 4 square, that is b square, that is 16, minus 4, a is 1, c is 5, that is 4 into 1 into 5. So after simplification, this quantity divided by 2a, after simplifying this quantity it becomes minus 4 plus or minus underscore root 16 minus 20, that becomes minus 4 divided by 2. So this can be written as a minus 4 plus or minus underscore root 4 means it is 2, underscore root minus 1 means it is imaginary, that is I. So it can be written as a minus 4 plus or minus 2i divided by 2. So after simplifying that, as taking denominator separately to this quantity and this quantity separately, it can be written as a m is equal to 2 ones are 2 twos are minus 2 plus or minus 1 into I. Therefore, the roots are complex in nature. Therefore, by the rule, the complementary function yc is written as e to the power minus 2x into, you can write a c1 and c2 also here. For convenience, I have written a and b. A is equal to cos x plus b is equal to sin x. This is the complementary function. Now, main thing is we need to concentrate on the particular integral. That is, particular integral is equal, that is why p is equal to 1 divided by LD of minus 2 times cos hyperbolic hx. Okay. Now we don't have this any method to find a particular integral when it is in the hyperbolic form. So we have to convert this into any of the 5 forms. So let us, using the basic definition of the cos hyperbolic function as cos hyperbolic theta is equal to e to the power theta plus e to the power minus theta divided by 2. Here in place of theta, if you put x here, this x becomes a minus 2, as it is becomes a e to the power x plus e to the power minus x divided by 2. So these two get cancels. So finally our function becomes minus you take common 1 divided by d square plus 4d plus 5 of e to the power x and plus e to the power minus x you will get. Now this is one exponential function, this is one exponential function. Okay, there are two x's, that is f of x, function of x. In this case a is equal to coefficient of x is 1, in this case this is minus 1. So we need to consider both here. Therefore so operating this, since this is a linear operator, we can operate it separately. Therefore 1 divided by d square plus 4d plus 5 of e to the power x plus 1 divided by d square plus 4d plus 5 of e to the power minus x. Now let us consider this case number 1 first. Here a is equal to 1. Now since a is equal to 1, we have to come back to this roots, and whether we have to check whether this a is equal to 1 is equal to this root or not. So here both the roots are complex in nature. This a is not equal to any of the roots, so directly we can write this one as e to the power x divided by L of 1. That is, wherever d is there in LD, we have to replace it by a is equal to 1 plus. Here again, in this case, we have to separately consider this. That is, a is equal to, you got minus here, minus 1, so you can consider a as minus 1. So again this minus 1 is also not equal to any of the roots, so directly you can write e to the power minus x divided by L of minus 1. Now let us substitute these in this case a is equal to 1 in the LD, that is 1 square plus 4 into 1 plus 5, and here also e to the power minus x divided by minus 1 square plus 4 into minus 1 plus 5. Now let us simplify this. This is e to the power x divided by 1 square, 4 into 1 is 4, 4 plus 1 is 5, 5 plus 5 is 10, plus e to the power minus x divided by minus 1 square is 1, plus into minus is minus, 1 minus 4 plus 5. So it becomes 5 plus 1 is 6, 6 minus 4, that is 2. Therefore, the taking this minus sign inside the bracket, therefore the pi, required pi becomes e to the power minus x divided by 10 minus e to the power minus x divided by 2. This is the required pi. Therefore, the required general solution is y is equal to yc plus yp, which can be written as y is equal to e to the power minus 2x into bracket a cos 2x plus, sorry, a cos x, I'm sorry, a cos x plus b sin x, 1 by 2 times minus 1 by 2 times e to the power x divided by 5 plus e to the power minus x. This because we have taken here, we have taken minus 1 by 2 common. So if you take e to the power minus 1 by 2 common, it becomes e to the power x divided by 5 minus this is e to the power minus x. So this is the, I'm sorry, so this is the required complete solution of this exam.